Okay, today we're going to be looking at static equilibrium question. And this time we have a plank which is held in equilibrium in a horizontal position against a wall. Let's have a look at the question. It says a plank AB of mass M and length 2A rests with its end A against a rough vertical wall. Right, so let's get a sketch going. The fact that the wall is rough means that there is going to be a vertical component of the friction, which I'm going to call Y. There will also be a horizontal force, a horizontal component of the normal reaction, which I'm going to call X, and that is our A. We've got the tension in the string here, and this is B. And the length of the whole thing, as we can see, is 2A. Okay, that's fine. So a small block of mass 3m is placed on the plank at the point P. So here we go. So we have a weight here of 3mg, and this distance here is x. Okay, that's fine, where AP is x. The plank is in equilibrium in the vertical plane, which is perpendicular to the wall. The angle between the rope and the plank is alpha, so alpha, where tan alpha is equal to 3/4. So let's draw our little triangle. So we have got tan is opposite over adjacent, so 3/4. There's our 5, there's our alpha. Okay, so that's going to be useful to us later in the question. The plank is modelled as a uniform rod, and the block is modelled as a particle, and the rope is modelled as a light inextensible string. Okay, that is great. Now, it tells us that the mass of the plank is m, and it's a uniform. So we have mg as the weight of the plank, which is going to be acting at a distance of a from the point A. And I think that's everything that we need for our sketch. So let's have a look at part A. Using the model, show that the tension in the rope is equal to that expression there. So when we've got to do this, I think it's going to be most helpful for us to take moments about A. Because if we take moments about A, what's going to happen is that's going to eradicate the vertical and horizontal components of this reaction force at A. So that will be really useful to us, because then we'll just have a clockwise moment coming from mg and 3mg, and we'll have the tension. So we should be able to find an expression for tension if we take moments about A. So it's in equilibrium, so our clockwise moments equals our anti-clockwise moments. And the sum of our clockwise turning moments is going to be mg times by A from the weight of the plank. Then we've got the object, which is going to be 3mg times by A. That's the turning component from that one. And that all equals the anticlockwise turning moment, which is going to be t sine alpha. Now it's sine alpha because the vertical component this is the opposite. So that's going to be sine alpha. So it's going to be t sine alpha times the distance, which is going to be 2a. So that's our clockwise moments and our anti-clockwise moments. Okay, so let's begin to factorize some things out here now. mg can come out, leaving us with a times by, we're going to have a there, and that distance is going to be 3x. Actually, I put 3mga there, but that should be an x, so it's going to be 3x. So there we go, is equal to t sine alpha. Sine alpha is going to be opposite over hypotenuse. So that is going to be 3/5 times by 2a. Okay, that's perfect. So now we can just simply times everything by 5 and divide by 6a. And that gives us the tension is going to equal 5 mg times by a add 3x all over 6a as required. So we found our expression there for the tension. Okay, that's great. Good, good, good. Now, let's look at the next bit, part B. It says the magnitude of the horizontal component of the force on the plank at A by the wall is 2mg. Find x in terms of A. So they're telling us now that this horizontal component here that I've called x is actually 2mg. So what we need to do for this next bit is we need to resolve horizontally. So if we resolve horizontally, we're just going to have the components of the 2mg and the component of the tension, because these will not be acting because they're perpendicular. So when we resolve horizontally, now we're going to get that 2mg is going to equal t, and it's going to be cos alpha, because this is the adjacent, okay? So t cos alpha. So our t cos alpha, just swap over the side, t cos alpha equals 2mg. Our t, we know from before, is our 5mg times by 3x add a, all divided by 6a, and that is equal to 2mg. And then we've got our cos alpha, and our cos is going to be adjacent over hypotenuse. So that's going to be times by 4/5. So we can do some cancelling out now with this one. So we can cancel out that 5 and that 5. And then the 4 and the 6 can go to 2/3. Okay, so that's looking good so far. And then we can also cancel out now a factor of 2 from both sides, there and there. Let's just write down what we've now got so far. What we've now got so far is we've now got mg is equal to, mg times by 3x add a. And that's all over, everything else is cancelled. We've just got a 3 there in the denominator, is equal to mg. Okay, so now what we need to do is we can cancel out our mg on both sides. Okay, so that's going to give me 3x add a is equal to 3. And we've got our a there as well. So we've got 3a there, so we have an a there. And then finally, now all we need to do is subtract the a, so we have 3x is equal to 2a, and therefore x is going to equal 2a/3. That's fine, so we just needed that a there as well. Perfect, so that is our expression for our x. It is equal to 2a/3 is our x. Okay, perfect, so we've now found out that's the part B for 2 marks. Next bit of the question. Okay, so the next bit of the question now, what does it say for the next bit? The next bit, it says, a force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. Find the value of tan beta. So what's happening now is we can imagine that the horizontal and vertical components of the friction, the sort of normal reaction, if they were combined, they would give us a resultant force here, R, and this resultant force would be making an angle of beta with the horizontal. Okay, so in order to, often in these kind of questions, they ask us to then subsequently find out what R is or find out what beta is. In this case, they want us to find out tan beta. So we need to find the vertical component of this reaction. We know the horizontal, we've been given that. So what we need to do now is we now need to resolve vertically. And it's going to be worth 5 marks, so we've got to be careful not to make any mistakes here. So let's resolve vertically. Okay, so resolving vertically, we've got y, and we've also got t sine alpha. T sine alpha. So those are our 2 vertical components. We've got that t sine alpha here, and we've got y there. And that is going to equal to mg plus 3mg. So those are our forces going down. Okay, so let's sub in our t. We know that t is 5mg times by 3x add a, all over 6a. That is going to be times by sine alpha, and sine alpha is 3/5. And that all equals 4mg over here, and that is our y plus that. Let's see if there's any, we also know, remember, that this x from before we've just previously found that x was equal to 2a over 3. So I think we ought to sub that in there as well. So y, and we're going to have plus 5mg times by 3 times by 2a over 3 plus a all over 6a times by 3/5 is equal to 4mg. So let's see what we can cancel out from here now. What can we cancel out? Right, so that 3 and that 3 will cancel, okay? And then the 2a, add the a, will become 3a. So let's just kind of take it steady here. 5mg over 6a. We've still got here 3/5 is equal to 4mg. We could cancel mg from both sides as well. Oh, no, actually, we can't cancel mg from both sides because of the way we've got a plus there as well. So we'll leave that for a moment. Let's see what else can cancel. The 5 can cancel there, and that 3 can cancel with the 6, and that can become just a 2a there in the denominator. So let's just write down what we've got so far. We've got y plus 3a mg all over 2a is equal to 4mg now. Okay, so that's fine. Everything's cancelled down in that way. Let's now subtract this over here and get our expression for y. So we've now got 4mg minus 3amg. The a's can cancel there. So that's quite useful, actually. We can cancel that a out. That's good. So we now have 4mg minus 3 over 2mg. So let's work that out. So basically we can think about this one as being like 8 over 2. So 4mg can be thought of as 8 over 2mg to get a common denominator. And now when we combine that, that's going to give us 8mg minus 3mg is going to be 5mg over 2. So we found our 5mg over 2 is our vertical component, okay, by combining all of that. Perfect, that's good. So far so good. So now what we've got to do is find out what tan alpha is, okay, tan beta rather. So tan beta is going to equal the opposite over the adjacent, so the y component over the x component. So it's going to be 5mg over 2 over 2mg, which they told us in the question. And that is the same as 5mg over 2 times by 1 over 2mg. So our mg's will cancel now, and we're going to have 2 times 2. So this whole thing is 5 over 4. So the answer to part C is that tan beta is equal to 5 over 4. And we found our answer to part C there. Tan beta is equal to 5 over 4. Okay, the last bit of the question now. It'd be quite easy to make a mistake there in that algebra, I think. So do be careful. The last bit of the question now, part C, part D rather. It says the rope will break if the tension in it exceeds 5 mg. Explain how this will restrict the possible positions of P. You must justify your answer carefully. So let's look and think about this. So the tension exceeds that. So let's write down our expression for our tension. So we're told that the expression for the tension is 5 mg times by 3x add a all over 6a. And we're saying now the condition is that this needs to be less than or equal to 5 mg, because it says if the tension exceeds it. So presumably the rope will not break if it equals it. So now all we've got to do is just rearrange this expression in order to find out what the limiting value of x is. Well, we can cancel 5 mg off both sides and times both sides by 6a. So that's going to give us 3x plus a is less than or equal to 6a. Take a off both sides and we have 3x is less than or equal to 5a, and divide both sides by 3. So x is less than or equal to 5a over 3. So what that means is, in order for the string not to break, the rope not to break, the position of P needs to be less than or equal to 5a/3 away from A. And that is the end of that 13-mark question. I hope that you found that helpful, and I will see you useful, and I will see you in the next video.